Alright, I feel like we've just done one like this, and we did. So in the beginning, you're going at a constant velocity. D equals Vt. Your V is 20 meters per second. And your time is 0.5 seconds. So, gee, this looks familiar. That's a 10, believe it or not. 10 meters. I'll fix that. 10 meters for part 1. Constant velocity, part 1. I get 10 meters. Part 2, decelerate. I need to know my distance, and I have a final velocity of 0, an initial velocity of 20, what else do I have? I have an acceleration of 10, which is going to be 10, or negative 10, because I'm slowing down, and I need to know change in x equals question mark. So let's use this equation. This will be 0, 20, change in x. Alright, so I'm going to move the 20 to the other side because that 0 just kind of goes away. But you have to square it. My change in x, I divided both sides by 2 and the negative 10 to get these to go away. It's 2, believe it or not. And this equals 20 meters. And I have to add the 10 from before, and that's 30 meters. Now they told you, that the deer was 35 meters ahead of you. So 35 minus 30 is 5 meters. So you missed him. Yay. Woo woo. Woo woo. Alright, this part B is nuts. I don't even know why I'm doing it. I don't think you'd have to do this on the EP test, but let's look at, this is just crazy. Let's look at our constant velocity part 1. You would have D equals Vt. And because this is going to get kind of weird, I'm going to leave this as x for displacement. Your velocity, we don't know what it would be. It'd be VO, your initial velocity max. That's what I'm going to call it. That's my new x. And my time is 0.5 seconds. So I have 2 unknowns. I'm kind of stuck with 2 unknowns. When you have 2 unknowns, you go to part 2. Part 2, I'm going to pull this one out. V squared equals V initial squared plus 2ax. And this one turns into, my final velocity goes away. I'm going to subtract my VO now is VO max. And I'm going to bring it to the other side, but it has to be squared. Equals 2a change in x, which is going to be VO max squared equals, what was that, 10? Now my change in x is really my 35 meters minus my initial x, because my distance is going to change. Right? If my speed changes, that distance is going to change, so I don't know what that is. So if you look at this, you have 2 unknowns again. This xo XO there. So I am going to substitute, let's go to a different color here. I'm going to substitute this every place I see an XO, which is down there. This is just crazy. VO max squared equals negative 20 meters per second squared. And this is going to be 35 meters minus VO max. You know what? I'm going to write, you'll see why in a second. I'm going to switch these two. I am going to go, I'm just going to switch it around. You'll see why in a second. 0.5 times VO max. I told you this was nuts. I'm going to distribute, and I believe this is negative 700 meters squared, seconds squared. I still have my negative VO max out here. And then I have to distribute over there, which would be plus 10 meters per second VO max. Is this crazy or is this crazy? This is totally crazy. All right, let's set this up like a quadratic equation. Let me look at my notes here. This would turn into VO max. I moved it to the other side. 0 equals VO max squared all right, I'm right. Plus 10 meters per second times VO max minus 700 meters squared, seconds squared. Now, if you go find, I don't know if you guys have these on your calculator or where you have them, but if you go find an quadratic equation solver, I just Googled it, and I got one answer to be 21.9. That'd be meters if we're looking for x. And the other one was negative 31.9, which means I went backwards. And remember, there's always one that doesn't really make much sense. So my answer is 21.9. Longest problem in the history of the world for part 2. It's crazy. Let's say we don't put one of those on the test, okay? Okay. Bye-bye.